On November 20th, 2025, the universe broke a rule. An X appeared in the sky where no comet should shine. Why did it flare after it passed the sun? And why does it now move as if it's not alone? That image changed everything. At first, it was just another quiet night, at least from Earth's perspective. But somewhere above, near the edge of our planetary shadow, something was beginning to glow. Not with the diffuse haze of a dust tail, nor the pinpoint shimmer of a bright star. No, this was something else. 4 limbs of light, crossing in near-perfect symmetry, emerged on the digital plate like a cosmic signature. It didn't fit, and that's exactly why it spread. Before the scientific journals could even decide what it was, the frame was already viral. Within 48 hours, the image had been reposted, colorized, zoomed, dissected, annotated, and, in some corners of the internet, canonized. X in the sky, the mark of Atlas, comet cross anomaly. The names didn't matter. What mattered was how the image made people feel, that something impossible had just made itself visible. And once that feeling sets in, you don't forget it. We weren't supposed to see this. That's what makes it matter. Telescopes across the southern hemisphere had been tracking C. 2023, a 3 nicknamed 3I, Atlas, for months. First catalogued as a fast-moving interstellar object, its path resembled a comet. But the deeper it fell toward the sun, the more its behavior resisted classification. It didn't brighten normally. It didn't shed debris. It didn't develop the typical coma. It just kept moving, silently, relentlessly, with jets, but no tail, with force, but no explosion, with structure, but no obvious rotation signature. And then, after perihelion, after the point of no return, it flared. Not from destruction, not from heat, but from geometry. 4 beams, 2 near horizontal, 2 curved, all extend from a single nucleus. Stacked images confirmed it. The X was real, not an artifact, not a glitch. Multiple observatories across South America and Africa reported similar configurations. Even amateur astrophotographers began spotting the shape with mid-range equipment. Every new sighting added to the mystery. Same angle, same brightness axis, same eerie stability. It was as if something was broadcasting. But broadcasting what, and to whom? Most objects flare unpredictably, triggered by fragmentation or sunlight scattering off volatile materials. But 3I, Atlas's flare wasn't chaotic. It was balanced, precise. If you drew a line from each limb, you'd get a symmetric cross that pointed roughly sunward on one axis and aligned with its previous jet direction on the other. Not random, not a smear of motion or a melting trail, a diagram, in light. That was the first moment many scientists felt it. The image wasn't just stunning, it was unsettling. Because the more we looked at it, the less it looked like a byproduct, and the more it looked like a message. But we didn't say that, not out loud. Instead, we clung to terms like vent alignment, outgassing axis, or differential rotation artifacts. We submitted our uncertainty to models, hoping they would explain the symmetry away. They didn't. The internet had no such hesitation. Within days, number Atlas X trended on TikTok and X. 1,000 interpretations flooded in, from alien navigation beacons to cosmic warnings to solar lensing anomalies. YouTubers ran 3D reconstructions. Redditors charted the angles with precision graphics. Instagram pages juxtaposed the X with everything from Egyptian Ankh symbols to Tesla's Starlink crossbeams. None of it was science, but none of it was dismissed, because in the space between knowledge and belief, something grows. Curiosity. And this time, that curiosity didn't feel aimless. It felt directed. The symmetry of the image wasn't just aesthetically pleasing, it felt intentional. And that one feeling, that whisper of intent, changed how people looked at the sky. They began asking, who made this? Why now? Is it watching? But there's a more subtle question behind those louder ones. What does it mean when the sky breaks its own patterns? For centuries, we've relied on repetition to decode the heavens. Orbits, reflections, periodicity. Every comet that shines follows a script written in gravity and dust. They flare as they approach the Sunday. They fragment or fade, and then they're gone, leaving behind a trail of evidence and prediction. But 3I, Atlas defied that arc. Its brightness peaked after perihelion, not before. Its flare was not random, but sculpted. Its geometry was not asymmetrical, but ordered. Its jets did not tumble, but stayed steady. Its path did not curve with drag, but remained consistent. Its motion did not suggest decay, but control. One by one, the hallmarks of chaos fell away, and in their place, something more unnerving emerged. Pattern. Pattern implies mechanism. Mechanism implies architecture. Architecture implies intent. We didn't say that, either. Not in public. Not in journals. But we felt it, quietly, uneasily, and perhaps most dangerously personally. Because if this thing is sending signals, if its form is chosen, not incidental, if what we're seeing is not just how it moves, but why it was shaped this way, then every assumption we've made about interstellar visitors must be reviewed not for what we've seen, but for what we might have missed. We never expected a message, but maybe that's the only kind we ever get. Not one shouted, but shaped. Not words, but light. Not volume, but geometry. And in that silence, there is a kind of elegance. A visitor from beyond, writing its presence across the sky, not with violence, but with balance. Not with shock, but with symmetry. Not with chaos, but with structure. Whatever it is, it's still moving, still visible, still shaped like a question we don't yet know how to ask. We thought we knew what it was. A comet. An interstellar one, sure, but still. A comet. A visitor, yes, but just passing through. The story made sense. It was even beautiful in its simplicity. Another rock from another star system, like Oumuamua or Borisov. A long arc through our solar system. A flash of light. And then, gone. That was the story everyone believed. Not because it was proven, but because we had seen something like it before. And when the sky sends us the unfamiliar, we anchor it to the known. It began with the orbit. On the 27th of February 2023, a fast-moving object was detected by the Atlas survey system. Its trajectory was steep, hyperbolic, and sunward, and the numbers didn't lie. This object wasn't part of our solar system. We named it C, 2023A3, but soon another name began to circulate, one that carried the weight of its predecessors, 3I, Atlas. The third interstellar object ever detected. We had seen two before. In 2017, there was Oumuamua, an oblong, tumbling mystery that passed silently through the inner solar system, reflecting no light and revealing no tail. In 2019, 2I, Borisov, followed a more traditional-looking comet with a tail and coma, but moving fast enough to be clearly unbound to our Sunday. Now, in 2023, came a third, and naturally, we thought we understood the category. 3I, Atlas, came with credentials. Its entry angle was steep, too steep to be gravitationally captured. Its velocity was high, exceeding the escape speed of the solar system. Its inbound trajectory traced back to far beyond the Oort cloud, past even the imagined realm of Planet 9. It was not from here. And so, our minds snapped into place. Interstellar comet, case closed. It helped that the object initially looked the part. It had a nucleus, faint at first. It had periodic brightness changes, and as it neared the sun, observers detected what appeared to be jets, signs of outgassing. It wasn't as weird as Oumuamua. It wasn't as ordinary as Borisov. It was something in between, and that was comfortable. We like categories that sit in the middle. When something is too strange like Oumuamua, it unnerves us. When something is too familiar like Borisov, it fails to hold our attention. But 3I, Atlas? It straddled both. We could point at it and say, it's a comet, but we could also whisper, but maybe it's not. It was just enough mystery to inspire YouTube videos and late-night discussions without ever threatening our frameworks. That's how you build consensus in modern astronomy, not by eliminating doubt, but by reducing it until it becomes background noise. And so, the public story began to crystallize. The major outlets ran headlines. Third interstellar visitor discovered new comet from outside our solar system. Astronomers track deep space wanderer. Explanatory videos followed, each reinforcing the same beats. It's not a threat. It's a natural object. It's exciting, but not alarming. Scientists used words like unusual, but not unexplainable. They spoke of peculiar jet activity, but not directed outflows. They noted its unusual stability, but never said control. The story was managed, not because anyone was lying, but because no one wanted to spark chaos. After all, the last time we got a truly strange interstellar object, we ended up in debates about aliens. Oumuamua changed everything, and we never really recovered. When it appeared in 2017, Oumuamua was unlike anything we had ever seen. No coma, no tail, no reflection curve made sense. Just a dim, rotating shard that accelerated without a visible mechanism. It was Avi Loeb who famously proposed an alternative. What if it were artificial? That single question fractured the scientific community. Some called it bold, others reckless. But it forced one thing: awareness. And when 3I Atlas arrived, many whispered the same question again. But they did it quietly this time. Because belief is dangerous. Because careers hang on objectivity. Because sometimes it's safer not to look too closely. So we built a new story. Safer, softer, more palatable. A comet, with some quirks, that just happened to be interstellar. It's amazing how quickly doubt can be papered over with consensus. How easily language becomes a barrier to wonder. We called it 3I, Atlas, but we treated it like 5I, Borisov. Because if it looked like a comet, and it moved like a comet, then surely it was a comet. Wasn't it? But the truth is, we didn't know. We still don't. Because all the labels we gave it, comet, interstellar, visitor, were based on fragments. Not just fragments of data, but fragments of pattern. We assumed it was natural because that's the most probable answer. We assumed it would behave like Borisov because that's what we wanted. We assumed it would fade into the night because that's what all the others did. And for a while, it did. Until it didn't. Because then came the flare. And the X. And everything we thought we knew about interstellar comets, about cometary motion, about the limits of natural outgassing began to crumble. Not all at once, not dramatically, but like tiny cracks in a windshield, quiet, spreading, irreversible. And for those paying attention, the question became louder than any answer. What if we were wrong again? It moved like a comet, but it didn't behave like one. That was the first crack in the model. 3I, Atlas had jets, but no coma. It emitted water vapor, but showed no signs of surface melting. Its spin should have destabilized the structure, but it stayed intact. These weren't minor anomalies. They were foundational violations, and science noticed. Let's begin with the coma. In every known comet, when it nears the sun, sunlight heats the surface, causing volatile materials like water, CO2, or carbon monoxide to sublimate. That process releases gas and dust, creating a glowing envelope, the coma. From Earth, that's often the first thing we see. It's the fuzzy halo around a bright nucleus. It's the visible proof that a comet is active. But with 3I, Atlas, the coma didn't arrive. Yes, there were jets. Yes, there was movement. But when stacked images were analyzed by amateur astronomers and ground-based observatories alike, what they saw wasn't a glowing envelope. It was structured, an X, a set of directed lines, sharp and geometric, crossing through the object's profile. No haze, no spherical envelope, just shape. This is more than aesthetic. A missing comma means less dust, less scattering, less outgassing. And yet, despite the absence of a visible coma, radio astronomers picked up a signal that shattered expectations. The 08-18 centimeter line. It's a very specific spectral line. When water molecules in space are bombarded with solar UV, they split into OH, hydroxyl, and hydrogen. That OH emits a faint but distinct signal at 18 centimeters in the radio band. We've used this signature for decades to confirm cometary activity. It's how we detect water even when we can't see it. In October 2025, MeerKAT detected it. Loud, clear, unmistakable. Which meant one thing: 3I, Atlas, was releasing water, lots of it. But if that were true, why was the coma missing? Jetting without a coma. Water vapor without explosion. And a shape, an X, that didn't match anything in our catalogue. The contradictions didn't stop there. Let's talk about the spin. Every object in space rotates. For comets, that spin is usually chaotic, irregular, tumbling, shifting over time due to jet torque. As material escapes the surface, it exerts a reactive force. This force causes precession, wobble, and often fragmentation. We've modeled this for decades. We've watched it play out in thousands of comets. We expect rotation to destabilize. But 3I, Atlas, didn't break apart. Instead, it appeared to stabilize. Amateur light curve data and early photometry hinted at a consistent spin pattern, not random, not chaotic. Some proposed axis locking, others suggested precessional damping. In any case, the data showed no increase in spin rate, no violent ejection, no rotational fragmentation. It was behaving too well. Then came the antitail. In classic comet dynamics, the dust tail always points away from the sunday. That's because solar radiation pressure pushes dust particles outward. But sometimes, under specific orbital alignments and viewing geometries, a phenomenon occurs where the tail appears to point toward the sunday. It's called an antitail. And it's not truly backward, it's an illusion caused by Earth's position relative to the comet's orbital plane. Except, with 3I, Atlas, it wasn't just visual. Multiple stacked observations confirmed a persistent linear structure extending toward the sun, even during periods when no such projection geometry should produce an antitail. And more troubling, that structure rotated with the object. That's not an optical effect, that's behavior. So now, let's summarize. By mid-November 2025, 3I, Atlas had emitted strong O-H radio signals without forming a traditional coma, sustained clear jet structures without corresponding dust halos, maintained a stable, low-precession spin state despite asymmetric jetting, displayed tail-like structures that moved counter to expected geometry, formed an X-shape that defied natural fragmentation models. Each one of these on its own might be explainable. Together, they are not. The laws of cometary behavior didn't just bend, they broke, and yet no explosion. This is critical. Thermal models suggested that by the time 3I, Atlas, passed perihelion just 0.39 AU from the Sun, it should have suffered catastrophic surface loss. Even low albedo models predicted surface temperatures high enough to vaporize subsurface ices and trigger runaway sublimation. But 3I, Atlas, stayed intact. No thermal breakup, no sudden brightening spike, no observable debris cloud. For comparison, dozens of sun-grazing comets have disintegrated under far less stress. So why didn't this one? Some theorized a hardened crust. Others suggested a non-volatile surface composition. But that contradicts the OH signal. Water vapor requires sublimation. Sublimation requires surface heat, and heat, in the absence of venting or spin cooling, should cause cracking. Again, it didn't, which brings us to the real discomfort. The energy budget doesn't add up. If it released water, but didn't sublimate enough ice. If it accelerated, but lacked visible mass loss. If it stayed cool, but orbited near the sun, then something is missing. Either our models are wrong, or something about this object isn't natural, not necessarily artificial, but unaccounted for. An unknown composition? A self-shadowing geometry? A layered vent structure? All have been proposed. None fit the full dataset. And the deeper problem? No one model explains all the anomalies simultaneously. Some explain the spin but not the jets. Some explain the OH but not the shape. Some explain the anti-tail but not the coma gap. It's like trying to finish a puzzle with pieces from 3 different boxes. You can force some pieces in, but the picture never makes sense. And every day, new images add complexity. Better resolution, stronger signals, stranger patterns. The laws aren't just being challenged, they're being rewritten. What happens when an interstellar object doesn't obey thermodynamics as we understand them? What happens when a body emits water but doesn't break? When it accelerates but doesn't vent visibly? When it spins but stays whole? Science doesn't panic, but it does pause. And in that pause, wonder grows. Because for all our models, for all our simulations, for all the confidence we've built from centuries of comet watching, we've never seen anything like this. Not even close. It should have looked like a comet. It didn't. It should have left a trail. It didn't. It should have brightened near the sunday. It didn't. but it moved and kept moving. That's the paradox. From the earliest days of comet science, there's been a simple formula. Proximity to the sun equals activity. Heat causes sublimation. Sublimation releases gas and dust. Gas and dust reflect light. Reflected light creates visibility. That's how we know a comet is alive. That's how we've identified them for centuries, first with the naked eye, then through photographic plates, and now via CCD sensors and deep sky stacking. But when 3I, Atlas, approached the sun, something strange happened. It stayed quiet, but it didn't stay still. Let's rewind to the basics. A coma is a visible atmosphere. When ices vaporize, the gas drags surface dust with it, creating a glowing shroud around the nucleus. It's not dense, it's not permanent, but it's the first sign of life. And for 3I, Atlas, there was nothing. Even after perihelion, even under solar pressure, even when thermal models said it should be outgassing, multiple observations in October and November 2025 confirmed it. High-resolution imaging from the Northern Hemisphere showed structure, but no envelope, no halo, no blur. You could see the body, you could see the jets, but not the cloud. That's not just rare, it's unprecedented. What about the tail? Comets leave trails. They eject dust that lingers behind them, creating long arcs of reflected sunlight. But image stacking from multiple skywatchers and observatories, Vera Rubin, Las Cumbres, amateur networks showed a clean path. No dust trail, no particulate glow, just motion, a nucleus. Isolated, intact, and yet somehow active. There was one strange exception, the antitail. As discussed in Part 3, some observers caught a faint structure pointing toward the Sunday. Normally, this is a projection illusion light scattering off large dust grains still near the orbital plane. But this antitail had structure, sharpness, motion. It wasn't just a backward blur, it was directional. It seemed to pivot with the nucleus. Some thought it was an artifact, others claimed it was venting just hidden from optical wavelengths. So researchers looked elsewhere. Infrared. If something is warm, it glows in infrared, even if it doesn't reflect visible light. Telescopes like JWST and NEOWISE can detect thermal signatures even from dark, non-reflective surfaces. It's how we find asteroids, brown dwarfs, and even distant galaxies. So teams began scanning. What they found raised more questions. The infrared brightness didn't match the outgassing levels implied by the OH 18cm line. It was too faint, too cold. This was an object close to the sun, venting water but not glowing like it should, which suggests one of two things. 1. It's colder than expected. 2. It's venting without surface heating. Both options strain physics. Let's talk about sublimation. It's the process that drives comet activity. You heat ice, and it turns to gas. That gas escapes, forms jets, carries dust, creates a coma, reflects light, and becomes visible. But what if the surface doesn't heat evenly? What if it vents only from shaded regions? What if it's designed or naturally shaped to channel pressure through specific zones? That could suppress the coma, it could hide the dust, it could reduce surface brightness. But it still doesn't explain the motion. Because here's the critical point. 3I, Atlas accelerated. Its trajectory shifted in ways consistent with jet-induced thrust. NASA's JPL tracked subtle but measurable changes in its motion, consistent with asymmetric mass ejection. But if the surface wasn't warming, if the coma wasn't forming, if the jets weren't visible, then where was the thrust coming from? One possible answer. CO. 2 jets. Carbon dioxide can sublimate at lower temperatures than water ice. It can release pressure from subsurface pockets. It doesn't always carry dust, and it's mostly invisible in optical wavelengths. If 3I, Atlas, had CO, 2 vents deep beneath a dusty crust, those could explain the motion. But that raises another problem. CO2 usually produces visible erosion. It cracks surfaces, it excavates jets, it creates evolving surface features. Nothing like that has been observed. No fragmentation, no changing albedo, no photometric chaos. Instead, the light curve remained smooth, stable, flat. That's not venting behavior. That's controlled behavior. So let's recap what the data shows. No visible coma despite confirmed water vapor via OH signal. No dust trail despite trajectory shifts that imply reactive thrust. No infrared brightening despite perihelion proximity. No observable sublimation despite movement consistent with jetting. And yet, it moved. It accelerated. It changed direction. This isn't just a failure of visuals. It's a failure of thermodynamics. If we can't see the source of energy, if we can't detect the heat, if we can't trace the dust, then what are we actually looking at? Could it be that we're missing the wavelength entirely? Could it be that something else, some deeper physical process is at work? One that doesn't require visible outgassing? One that doesn't leave a tail? One that doesn't reveal itself through brightness? There is precedent. Some interstellar objects like Oumuamua also lacked a coma, also lacked a tail, also accelerated, and in those cases, models were stretched to explain it. Porous outgassing, thermal lag, non-uniform material breakdown. But 3I, Atlas, is different because it flared. It had jets, it had structure. It's not featureless, it's selectively invisible. That's even stranger. Imagine this. You're watching a boat move across a calm lake. You don't see the oars. You don't hear a motor. You don't see a wake. But it's moving. Smoothly. Deliberately. That's what 3I, Atlas, is doing. It's sailing through sunlight. Without leaving a ripple. There is a term in science for this kind of phenomenon. Activity without signature. It's used when an object displays the effects of a process without the evidence of that process. It's a red flag. It means something is wrong with your detection method, or something is wrong with your assumptions. Either way, it means the story isn't over. And in the case of 3I, Atlas, the silence is part of the signal. No coma, no tail, no heat, but motion. Real, trackable, measurable motion. And that motion leads it toward Earth. If a comet spins, its jets should sweep. If it rotates, the vents should wobble. But this one doesn't. Its jets don't move. They lock in place. And that's a problem. When you watch a comet over time, you expect motion. Not just orbital motion, but rotational rhythm. The nucleus spins. The vents change angle. The jets flare in arcs, spiraling, sweeping across space like a lawn sprinkler caught in zero gravity. This is called precession. It's normal. It's predictable. It's how we estimate spin periods, pole orientation, and internal structure. But with 3I, Atlas, that didn't happen. Let's begin with what we do know. By late November 2025, observers had logged consistent jet features, especially one dominant feature from the trailing hemisphere. It was long, sharp, stable. Multiple teams reported that this jet maintained its orientation over multiple nights, not just hours, days, and across different instruments. Optical telescopes, infrared imagers, even polarized filters. It always pointed the same way. How is that possible? Let's assume 3I, Atlas, is spinning. It must be. The light curve shows modulation, periodic brightening, and dimming. This implies a rotating body with an uneven shape or albedo. Early models estimated a spin period of 8 to 11 hours, based on those fluctuations. So, a jet anchored to the surface should arc around as the body spins. But it didn't. The jet stayed fixed in space. That's not just confusing. It's mechanically inconsistent. To understand why, imagine holding a garden hose. You spin slowly in place. The water sprays in an arc. Anyone watching from above sees the stream sweeping in a circle. That's precision. Now imagine you spin, but the water always flows straight backward, unchanging. It's like the hose is anchored to the stars, not to your hand. That's what 3I, Atlas, seems to be doing. The jet doesn't follow the body's spin, it defies it, so we're left with a puzzle. There are only a few ways this could happen. 1. Aligned spin and jet axis. If the vent is exactly on the spin axis, then the jet won't precess, it'll point the same direction as the body rotates. But this requires nearly perfect alignment, which is rare. 2. Slow or no rotation. If the nucleus isn't spinning, then the jet can stay fixed. But this contradicts the observed light curve modulation. 3. Controlled jet orientation. If something inside the object is adjusting or restricting the jet direction, then maybe the flow stays locked despite rotation. But this implies internal regulation. Each of these options has implications. Each of them is uncomfortable. Let's look closer at option 1, spin-aligned vent. This would mean the vent is located directly on the north or south pole of the object's spin axis. If true, then the jet could stay straight as the body rotates. But even in that case, the surrounding ejector should still spread. Dust doesn't follow perfect lines. Gas expands, turbulence kicks in. Instead, the jet appears collimated, narrow, smooth, tightly bound. That's not normal. That's engineered behavior. Even natural collimation like that seen in geysers on Enceladus or jets on 29P, Schwarzmann-Wachmann, still shows oscillation over time. 3i, Atlas, no deviation, no spread, no jitter. Now let's entertain option 2, no spin. Maybe the nucleus isn't rotating, or maybe it's tumbling so slowly that we can't detect the precession, but the photometric data disagrees. Multiple observatories recorded a periodic fluctuation in brightness. The dips and peaks repeat every 9 hours. This is consistent with a body that has an elongated shape or albedo variation and is spinning, so a non-rotating object doesn't match the data. Even more, if it weren't rotating, the jets would induce torque. Reactive thrust from the jets would cause it to spin up, so the more it vents, the more it should rotate, the more WED-C changes. But again, we don't. That's the paradox. Which leaves us with the strangest possibility of all. Option 3, dynamic orientation control. Something is keeping the jet pointed. Not gravity, not inertia, not random chance, but regulation. Now, this doesn't automatically imply technology. There are hypothetical mechanisms like thermal inertia, subsurface channels, or active crust dynamics that could, in theory, maintain directionality. But those mechanisms come with side effects: jet flicker, dust diffusion, heat blooms, rotational drift, none of which are observed. Instead, we see persistence, stability, a jet that acts like it knows where to point. This raises an uncomfortable question. Why would the jets not precess unless they were meant not to? This isn't about conspiracy, it's about modeling. When you build a thermal model for a spinning body, you assume 1. The spin creates angular drift in vent orientation. 2. The jets follow surface geometry. 3. Ejector fans out over time. Every one of those assumptions fails here, which means we're not just wrong about the object, we're wrong about how it's behaving. There's one more layer. The 0818 cm radio signal discussed earlier comes from photodissociation of water vapor. This tells us the object is venting water, not just CO2, but water vapor sublimation is highly temperature sensitive. It should vary with surface exposure, and exposure varies with rotation, so we should see flux in the radio line. We don't. MeerKAT detected the OH line multiple times each time at roughly the same strength. This implies the outgassing is steady, the source region is constant, the orientation doesn't change. It's a consistent jet from a consistent location in a consistent direction. That's not typical behavior. That's coordinated. At this point, the burden of proof shifts. If a natural object behaves unnaturally, if it violates expected spin-jet correlations, if it defies thermal variability, then we have two choices. 1. Stretch the models to fit the behavior. 2. Ask if our model is wrong. Both are valid, but only one leads forward. We're not saying this is artificial. We're saying this is structured, and structure without explanation demands inquiry. Because if the jets don't precess, and the rotation doesn't modulate the thrust, and the spin axis doesn't realign, then we're watching something rare, something intentional, or something we simply don't understand yet. Either way, it's still jetting, it's still moving, it's still pointing, and that pointing might matter. It didn't come as a flash, it didn't come from a telescope, it came from a whisper, a signal 18 centimeters long, carried by nothing but silence, and in that silence we heard water. For weeks, people had asked, is it real? Is it natural? Is it active? And for just as long, the answers stayed blurry. No visual explosion, no tail wide enough to explain its push, no coma shimmering in infrared, only motion, only acceleration, only questions. Then, on a quiet night, across a dry landscape in South Africa, a network of radio dishes turned to the stars, not to see, but to listen. The instrument was MeerKAT, a radio interferometer, a forest of ears in the Karoo, and what it heard would change the conversation around 3i, Atlas, forever. Here is what happened. On the 11th of November 2025, a team of astronomers pointed MeerKAT at 3i, Atlas. They weren't looking for light. They were looking for a signature, specifically the 18-centimeter line from hydroxyl OH molecules. Why OH? Because OH is a daughter product. It forms when ultraviolet sunlight breaks apart. Water, H, 2O. Water splits into H and OH, and O emits a faint signal at a precise radio wavelength, 18 centimeters. So if you detect O8, you're detecting water vapor, and if you detect water vapor, you're detecting active sublimation. A comet is breathing. The signal came in, faint but clear. A spectral bump at exactly the expected frequency. It matched the predicted Doppler shift for the object's velocity, and it repeated on multiple scans. There was no doubt 3i Atlas was outgassing water. This changed everything, because until then, the outgassing was inferred, guessed from motion, shape, and geometry. But now, it had a fingerprint, an emission line, a direct measurement, physics. This wasn't imagination. This was spectroscopy, and in science, spectroscopy is the truth. Let's step back and see why this matters. Until the detection, the main argument against 3i, Atlas being active, was visual. No coma, no tail, no drama. Comets normally advertise themselves. They glow, they streak, they shed light like sparks off a wheel. 3i, Atlas didn't. It stayed dim, focused, contained. That led some to argue, it's inert, it's just reflecting light. No jets, no gas. But jets don't have to shine, they just have to leave a trace. And O is that trace. MeerKAT didn't just confirm outgassing, it confirmed the type of gas. Not carbon monoxide, not dry ice, but water. This means the object is warm enough to sublimate ice, or at least portions of its surface are exposed, and it means energy is flowing from the sundae into the body, out through the jets. But then comes the paradox. If it's outgassing water, where is the coma? Where is the light scatter? Where is the fluorescence? The signal strength of the OH line suggests a decently high production rate. Not explosive, but steady. That should create a visible halo. And yet, deep image stacking with long exposures found no such halo. It's like the vapor evaporates into geometry, not into glow. That's silence, again. Some scientists propose that the gas is escaping through a narrow vent, a jet so collimated that it doesn't create a diffuse coma. That would match the observed jet behavior. Directional, consistent, invisible to the naked eye. Others floated the idea of low albedo shielding, a surface so dark it absorbs rather than reflects, hiding the outgassing in thermal noise. But both theories still fail to explain the stability, because the OH line strength didn't flicker. It remained consistent over time, which implies the jet didn't vary. Which brings us back to control. This is where the speculation deepens. What kind of natural object? Vents water, shows no coma, has stable jet orientation, and releases constant output despite rotation. That's not a comet. That's a design. And yet the models strain to keep it in the natural box. Why? Because the alternative is unsettling. Let's consider another scenario. What if the vent isn't on the surface, but embedded deeper, shielded from direct solar flare? What if the outgassing isn't solar-driven, but internally regulated by phase change, delayed conduction, or even pressurized chambers? Such mechanisms could explain the delay in activity, the consistency of output, and the absence of visual flares, but they would also imply a highly specific internal structure, which again leans closer to intention than chance. There's also this. The 0818 cm line has a history. It's been used since the 1970 seconds to map water in comets, from Halley to Hyakutake to Hale-Bopp. In all those cases, the line came with drama, bright tails, massive comas, visible jets, 3i. Atlas gave us the line, but none of the drama. It's like a whisper in a library. After watching fireworks, quiet, precise, unmistakable, the detection was reported in early December. But MeerKAT wasn't the only one listening. Other radio arrays began scheduling follow-ups. Some tried to replicate the detection, others scanned for additional molecular lines like CN, CO, or HCN. But so far, only O has been confirmed. That might say something about the composition, or about the process itself. A jet that releases water, and little else. A probe, perhaps? That word keeps returning. Probe. Not because we want it to, but because the object acts like one. It moves deliberately, it vents discreetly, it signals chemically, and it resists fragmentation, all while remaining silent until someone tunes to the right frequency. And when they do, they hear water. Water, the solvent of life, the universal bridge, the signature we follow to find others. The 0818 cm line is not just a detection, it's a conversation between sunlight and ice, between physics and chemistry, between one world and another. We didn't see it with our eyes, we heard it with our instruments. And what it said was simple. I'm real. I'm active. I'm here. It didn't need a tail to speak. It didn't need a flare to announce itself. It just whispered on the radio and let us do the rest. And now that we've heard it, we can't unhear it. It came close, too close. And by every model we know, it shouldn't have survived. But it did. And that silence, that survival, it is louder than any explosion. Perihelion, the moment of closest approach to the Sunday. For 3i, Atlas, that moment came on October 11th, 2025. It passed within 0.26 AU, less than 40 million kilometers from the solar surface. Closer than Mercury, closer than many comets dare. It was a trial by fire, and everyone expected a reaction. Here is the physics. As a comet approaches the Sun, solar energy increases dramatically, not linearly, but as an inverse square of distance. At 1 AU, you get 1 unit of solar flux. At 0.5 AU, you get 4. At 0.26 AU, more than 14 times the energy per square meter than Earth receives. That's not sunlight, that's a furnace. Now apply that energy to an icy body, even a small one, and you get chaos, sublimation, surface fractures, thermal stress, outbursts, fragmentation. This is why so many sun-grazing comets don't make it. They flare, split, evaporate, or disappear. But 3i, Atlas, it stayed whole. No flare, no brightening, no debris, no fading, just continuous motion. And if you model it, that doesn't make sense. Let's walk through the thermal budget. At perihelion, an object receives enormous radiant energy. That energy must be absorbed, reflected, or re-radiated. Some of it goes into heating the surface, some into sublimating volatiles like water, CO2, or CO, some into internal conduction. If the object is porous, heat can penetrate and create internal pressure. If the heat is too much, pressure builds until the structure fails. Boom. It's not a question of if, it's a question of when the materials can't take it. And that threshold, for 3i, Atlas, should have come days if not hours after perihelion. But nothing happened. The absence of an outburst wasn't subtle. Observers around the world were watching. Professional astronomers, amateurs with stacked CCDs, infrared arrays, even spacecraft solar imagers like SOHO and Stereo. They saw a curve, a pass, a fade. No sudden spike, no bright plume, no breakup trail, just one intact point of light, moving on. So what happened? Option 1. It's made of rock, dense, tough, inert. That would help explain the survival, but not the jets, not the OH line, not the sublimation. Rocks don't outgas water. Option 2. It's coated in a high albedo shell, a reflective surface that shields it from heating. That could reduce thermal load. But again, why the jet? And why the spin-link directionality of that jet? If it's just reflecting, it shouldn't vent selectively. Option 3. It's venting through a narrow, engineered geometry, a heat-resistant jet port that releases pressure with precision. This would match everything we've seen. No coma, no flaring, steady OS emission, directional thrust, structural survival at perihelion. It's not proof, but it is a pattern. And patterns are how we begin to suspect. Some scientists ran survivability models. They input a nucleus radius of to 120 meters, spin rate consistent with light curve data, typical ice-rock mixture, perihelion flux at 0.26 AU, and the models broke down. Even assuming perfect thermal re-radiation, the sublimation rate exceeded structural tolerance. It should have shed mass. It should have lost spin stability. It should have fractured. Instead, it coasted through, calm as a pebble in moonlight. That's not luck. That's insulation, or control, or something else. The idea of an energy budget deficit took hold. It goes like this. Input energy is greater than observable output. If the sun delivers X joules per second, and we only see Y joules expressed in heat, light, and motion, then something's wrong. Where is the missing energy? Was it stored? Was it redirected? Was it used in ways we don't understand? This opens a deeper mystery. We tend to think of explosions as signs of energy, but sometimes the absence of an explosion means better energy management, like a pressurized tank that vents just enough to maintain integrity. Not too much, not too late. That's a system, a feedback loop, not a random pile of ice and dust. Let's consider a thought experiment. Imagine a small probe, encased in thermally resistive material. It approaches the sunday. It activates passive cooling via gas venting, not for propulsion, but for balance. It spins slowly, stabilized, not tumbling chaotically. Its outgassing is constant, not eruptive. Its profile remains dim, non-reflective. Now compare that to 3i, Atlas. How many differences do you count? Or rather, how many overlaps? The only thing missing from a traditional explosion was the spectacle. There was energy, there was stress, there was chemistry, but no display. It's like watching a bullet go through a fire and come out the other side unburned, not because it's indestructible, but it was designed to endure that temperature. Designed, not evolved. This puts pressure on the natural hypothesis. If it's a comet, it breaks known cometary behavior. If it's a rock, it breaks spectroscopic and kinematic evidence. If it's a hybrid, we're in uncharted territory, and that means the old playbooks no longer apply. It demands a new model, one with internal cavities, thermal resistance, jet control, structural cohesion. No known comet has all four. So we ask, what is 3i, Atlas, really? In the days after perihelion, as the object continued outbound, some thought it might fade and fragment, delayed reaction. But that didn't happen either. It stayed active, it stayed intact, it stayed silent. The post-perihelion window, typically the most violent, was uneventful, which brings us to the final paradox. The closer it got, the calmer it became. There's a lesson here. Sometimes the greatest mysteries don't come in the flash. They come in what doesn't happen, not in the explosion, but in the absence of one, not in the data spike, but in the flatline that defies it. 3i, Atlas, didn't explode, and that may be the loudest thing it's ever said. What kind of visitor leaves nothing behind? No ashes, no whispers, not even a shadow. Only its silence still glowing, still alone, as if it was never meant to be followed. When something breaks, it leaves evidence, a crack, a splinter, a trail. That's how we know things have happened. It's how we map events in space. We follow the fragments. But 3i, Atlas, didn't break. And it left no trail, just motion, just presence. And then it moved on, without a signature. For most comets, trails are inevitable. Sublimation drives dust outward. Solar pressure and gravity stretch that dust into a line, a glowing, particulate memory. It doesn't require an explosion, just heat and distance. The coma may fade, but the dust lingers. C. 2020 F. 3 Neowise had one. C. 2011 L. 4 Pan-STARRS had one. Even Oumuamua showed signs of faint forward dust dispersion, but 3I, Atlas, nothing. No tail, no fan, no streak, not even in stacked images. And that's the key, because even when a trail is faint, we can amplify it. Astrophotographers stack dozens, sometimes hundreds of exposures. They align each frame on the nucleus. Background stars blur, noise drops, faint features rise, dust trails appear. It's not magic, it's statistics. Signal floats above the noise. Real structure becomes undeniable. We've done this with dozens of comets, even broken up ones. But when they tried this with 3I, Atlas, nothing. Just a single point. Sharp, isolated. No fade, no smear, no tail. This isn't just odd, it's unphysical, because we know it's active. MeerKAT detected O8 at 18 centimeters. That means water. And water, outgassing, under solar heat, must carry dust. Unless the dust isn't there, or it isn't being released, or isn't being tracked, because it doesn't behave like cometary dust. Let's explore that. What could prevent a visible trail? Option 1. No dust at all. An object composed of pure volatiles like CO2 or H2O could sublimate cleanly. But 3I. Atlas isn't bright enough to be all ice. Its surface isn't flaring. It's dark, subdued. So, something solid must be there. Option 2. Extremely large dust grains. Big particles scatter light weakly. They don't glow. They fall behind slowly. That might explain the missing glow, but not the missing trail. Stacked images should reveal geometry, and yet, still no evidence. Option 3. Controlled venting. If outgassing is highly collimated like a narrow jet, dust might be released in a compact vector, not diffused, not fan-shaped. This would look less like a comet, and more like propulsion. But even jets, over time, leave a wake, a streak, a whisper of dispersion. Yet here, silence. There's a fourth option, one that feels more unsettling: no trail. Because no fragmentation, no shedding, no loss, no erosion. It didn't flake, it didn't peel, it didn't comet. It held itself together, like a machine designed not to lose mass, even under duress. Like it had a purpose in remaining whole, like it was built to return. Some observers began to speak carefully. Not comet, but object. Not debris, but signal. Not tail, but absence of tail. They were describing a ghost. Not for what it revealed, but for what it refused to leave behind. It wasn't being evasive. It was simply indifferent. And indifference, in space, feels like intent. In post-perihelion images, the skywatching community tried again. Long exposure sequences, luminance stacking, infrared enhancement, still nothing. If a fragment had broken off, even a small one, it would drift, it would glow under solar radiation. But every image came back the same. One dot, isolated, constant, not dimming fast, not flaring, not splitting. And so came the question, is it hiding something, or is it something else entirely? We're trained to expect decay, to assume that comets, like stories, unfold, erupt, and fall apart. But what if that metaphor doesn't hold? What if some objects don't come to dissolve? What if they come to pass, quietly, intact, unforgettable, not because they scatter, but because they don't? This is where the psychological weight settles. We expect trials because we crave continuity. We want to trace the arc, to follow, to remember. A visitor that leaves no trail robs us of closure. It gives us only the now, only the passing. It's like a whisper in a language you can't record. You hear it once, you turn, and it's gone. Symbolically, it becomes something more. Not a comet, not a message, but a test of how we see, of how we define events. 3I, Atlas, left nothing behind, and in doing so, it became unforgettable. A point, a presence, a question. The final attempts at detection were desperate. High contrast filters, dynamic range compression, Doppler tracking. Even with the Vera Rubin Observatory's early sweeps, no debris was seen, not behind, not around, not fading. One solid light, headed outbound. That shouldn't be possible. It's not just rare, it's unprecedented. For an object to outgas and not leave a visible trace, to generate thrust without residue, to survive perihelion without fracturing, to exit without a footprint. But here we are, on the other side of perihelion, past the watchpoints, into the outbound phase, and all we're left with is this: a line of motion, a radio signature, a still frame where no trail formed. That silence, that missing trail, is its own kind of presence. We look back and see nothing, and somehow that nothing feels more deliberate than any debris field ever could. Not every mystery needs to be an answer. Some only ask, what if nature still holds cards we haven't seen yet? Let's begin with fairness, because before we leap into the extraordinary, before we whisper of engineering, messages, or deliberate design, we owe it to the sky and to our own minds to ask, what if this is still natural? Science lives in this space, in the narrow band between anomaly and assumption, between known and unknown, between what we can simulate and what resists simulation. So, for a moment, let's step back from suspicion, let's fold our metaphors, let's drop the drama, and let's test the best natural ideas we have. First, jetting. 3I. Atlas is active. That's no longer debated. The OH 18 cm line detected by MeerKAT means water is being released. Not maybe, not metaphorically, chemically, physically, outgassing is happening. So, what causes that? The traditional model is sublimation. Ices H2O, CO2, CO heat under sunlight, turn to gas, and burst outward. This gas carries dust. The dust reflects light. This makes the coma, the tail, the glow. But 3I, Atlas, shows no visible coma, no dust, only jets, and motion. So, let's adjust. Maybe it's a comet with CO2, driven jets, like C 2014, UN 271, Bernardinelli Bernstein. CO2 sublimates at colder temperatures than water. It can activate far from the sunday, and in theory, it doesn't always carry much dust. That explains early jetting. It explains O8 signals as byproducts. Plausible. Now the shape. Some models propose that 3I, Atlas, has an irregular, tumbling shape with vents in stable locations. Picture a potato lumpy, rotating, not evenly illuminated. Depending on the spin, certain spots face the sun more. They vent more. They accelerate the object. We've seen this before. Oumuamua's light curve hinted at a non-spherical shape, elongated, chaotic, but natural. So maybe 3I, Atlas is like that, but with just enough symmetry to avoid disintegration. Then, the axis. One paper suggests a spin-axis lock, a state where the jets stabilize the rotation rather than destabilize it. Imagine a top spinning while a small puff of air pushes it, not to tip it, but to keep it steady. If the jet is aligned near the rotation axis, you can get sustained acceleration. Without wobble, that could explain the non-precessing jet. No flickering, no spirals, just a clean, sun-facing vector. Simple, elegant, natural. Now, the anti-tail. A known optical illusion. In some comets, dust trails appear to point toward the sunday. This happens when Earth crosses the plane of the dust's orbital sheet. The tail doesn't really curve forward. Our angle of view makes it look that way. It's rare, but not new. Comet Arend-Roland did it in 1957, Comet Lulin in 2009. So, if a faint trail existed, an anti-tail geometry might hide or distort it. Add faint dust, long exposure noise, and stacking artifacts. Maybe we missed something. Still with us? Good. Because if we pull all these together, we can try to construct a fully natural model. Here it is. A small, dark interstellar object, mostly icy, low albedo, irregular in shape, passes into the inner solar system. It starts venting CO2 early. The jets are weak, but aligned along its rotation axis. This creates a stable, sunward push. MeerKAT detects the water products, but the dust is minimal. Grain size is too large. The emission is too narrow. No coma, no tail. But still acceleration, no explosion, because the internal structure resists thermal stress. And no fragments, because it stays intact. Plausible? Yes. Unusual? Very. But nature allows for rare combinations. Here's the challenge. To accept this model requires us to believe that every unusual aspect happens together. That 3i, Atlas. 1. Vents just enough to move 2, but not enough to fragment 3, with jets aligned perfectly to its spin 4, with no observable dust 5, while remaining active across perihelion 6, and still showing no trail or coma 7. And doing all this more consistently than any known comet. It's not impossible, it's just stacked, like flipping a coin 7 times and getting heads every time. Can it happen? Yes, but probability whispers. Skepticism doesn't mean rejection. It means holding the model up to the light and asking, does this fit? And if it doesn't fit cleanly, we don't discard the model, but we note the friction. We document the stretch, we mark the edges. We say, this works, but barely. This explains most. This holds until it doesn't. Because science isn't faith. It's flexibility. It's trying every key, even the unlikely ones, before you say, the door won't open. So we try the natural key. We turn it. We listen. And maybe the lock turns. Or maybe it sticks. But we try. And here's where humility lives. In accepting that sometimes nature presents something new, not because it's unnatural, but because we haven't seen it before. Just as once we thought lightning was anger and meteors were omens, maybe 3i, Atlas is only rare. Not wrong, not made, just misread. Still, one thing haunts us. Natural models can be stretched, they can be adapted, they can be fitted around data, but they shouldn't require too much adaptation. The more variables we adjust, the more special conditions we add, the more the model feels built to fit the outcome. And science, at its best, doesn't retrofit truth. It predicts it, so we stand in this space, half satisfied, half conflicted. This might still be a comet, just one like no other. And that, in itself, is worth listening to. It spun with precision. It accelerated with no tail. It survived when it shouldn't have. What if that's not a coincidence, but a choice? We've stretched the natural model. We've rotated every axis, modeled every vent, and leaned into every cometary edge case we could justify. But the lock is still sticking. Not broken, just resisting. So, now we ask the question. Many are afraid to. What if this wasn't an accident? What if it were engineered? Let's be clear. This is not a leap to aliens. This is not clickbait conspiracy. This is engineering logic. A discipline of intent, of constraints, of solutions to problems that don't solve themselves by chance. And 3i, Atlas, solves too many problems, too cleanly. Let's start with the vent. In nature, sublimation is messy. Vents open where heat strikes. They crack chaotically, spraying dust, changing direction, breaking structure. But 3i, Atlas, has shown a single, sun-facing, non-precessing jet. For months, that's not normal. That's not expected. That's not unstable. That's aligned. Now, imagine you were designing a probe to navigate a solar system using no fuel, only sunlight and controlled material loss. You'd want one vent, aligned to your spin axis, facing the sun day emitting only when needed, with materials that survive perihelion, with symmetry to avoid wobble. And that's exactly what 3i, Atlas, is doing. Here is where it gets stranger. This object spins, but the jet doesn't spiral. In comets, rotation causes jet precession. The jet scribbles light into arcs. But here, it's constant, straight, stable. The jet acts like a thruster. That's a very specific signature, not a chaotic release. Vector thrust. Avi Loeb, Harvard astrophysicist, called this venting control. He pointed out that a non-gravitational acceleration with no visible tail, combined with a light curve consistent with tumbling stability, could suggest deliberate surface geometry. He compared it to a sail, but not one made of fabric, one made of logic. Then comes survivability. At perihelion, 3i, Atlas, endured solar heating, far beyond what fragile comets usually withstand. Thermal models predicted it should have cracked, outgassed violently, fragmented. Instead, it stayed whole and kept jetting. That's not just lucky, that's robust, that's resilient under stress. In engineering, you design for the worst case, and this object handled the worst case as if it expected it. Now the absence. There's no coma, no debris trail, no fragmentation cloud behind it. If this were a natural comet, some particles should be trailing, even fine dust, even slowly dissipating haze. But deep stack imaging found nothing. It came through the system. Like a ghost, nothing followed it, nothing fell from it, and yet it still moved. Somehow, with no explosive discharge, no chaotic spin, no multi-vent chaos, it accelerated, it adjusted course, it navigated. That word navigation is dangerous. It implies purpose. So instead, let's say, it reacted, it adapted, and that's still enough. To raise the next question, what if the jet isn't random because the object isn't passive? What if the spin is stable because it was meant to be? What if 3I, Atlas, isn't it just surviving? What if it's designed to endure? Not forever, not loudly, but just long enough to pass through and leave us wondering. This doesn't mean aliens, not immediately, not necessarily, but it does mean design logic is on the table. Design is when form follows function. And here, the form solves too many functional challenges: non-gravitational thrust, minimal energy waste, high survivability, directional consistency, visual stealth. These aren't just traits, they're features. The question becomes, could these features arise naturally? Yes, if you're willing to stretch. But that's the point. Why do we keep stretching? Why does every natural model feel like a retrofit? Why do we keep layering exceptions on exceptions? Maybe because we're trying to explain a tool as if it were a rock. In 2023, Loeb's Galileo project examined fragments from the ocean floor, linked to IM-1, a possible interstellar object. The materials showed unusual sphericity, microspheres of metallic composition. Now, those aren't direct evidence of design, but they aren't random either, and they hint at something else. If something came before, maybe something is coming again. Let's ask the engineering question another way. If we had to build a probe to survive a long interstellar journey, enter a solar system, gather data, adjust its motion using no onboard fuel, stay stealthy, and leave, would it look different from 3I, Atlas? Would it really? Maybe it's not transmitting. Maybe it's not alive. Maybe it's just passing through, just as the design intended. It doesn't have to talk to us. It doesn't have to stop. It only has to do what it was designed for, and then disappear. That silence is its language. That stillness is its posture. It says, "I'm not here for you. I'm here for the stars. You just happened to be looking. We didn't intercept it. We didn't send a probe. We barely noticed." But now we ask, what did we miss? And how many more have passed unseen? Because now we know. It moved without rockets. It endured without breaking. It left no trail. It didn't speak. It didn't wait. But it was real. And maybe it was meant to be real. Just long enough for someone like us to notice. You can lie with light, but not with spin. Spin tells you who an object is, even when it says nothing else. Of all the mysteries surrounding 3I, Atlas, it's missing a tail, its perfect jet, its survivability near the sun. Perhaps none is more telling than the way it spins. Because spin, it isn't something you can fake. It's the fingerprint of motion, the rhythm of mass and time. And 3I, Atlas, spins like it knows exactly what it's doing. Let's rewind. When an object from deep space enters our solar system, we try to measure its rotation, n, the same way we've done for decades. We watch the light curve. That's the subtle rise and fall of brightness, as sunlight reflects off different surfaces while the object turns. Over time, this builds a profile, not just of its shape, but its motion. What did 3I, Atlas, show? First, stability. The light curve wasn't chaotic, It wasn't pulsing like a tumbling stone. It showed a consistent pattern. This means we're not dealing with a loose, asymmetric spin, not a broken fragment, not a comet splitting apart. This is an object in rotational balance. That alone is rare. Most natural comets wobble. They shed angular momentum. As they outgas, jets push them unpredictably. They tumble, they precess. Their spin rate changes, but not this one. Even as it jetted, its spin held steady. That's strange. That's elegant. That's not what you expect from an ice ball being cooked by a star. Then comes the axis. Using modeling and brightness harmonics, scientists inferred that 3I, Atlas likely, spins along a fixed axis, not tilted randomly, but pointing consistently, even across hundreds of hours of observation. And here's where it gets chilling. The spin axis aligns almost perfectly with the direction of the jet. This is not a coincidence. This is engineering geometry. In physics, when you want to vent material without introducing torque, you vent along the spin axis. That way, you don't destabilize the rotation. No twist, no wobble, just propulsion. And that's exactly what we see. Let's translate this to plain logic. It's spinning. The spin is stable. The spin axis is known. The jet aligns with that axis. The jet is consistent. The spin rate isn't changing. Together, these suggest a system. That's self-regulating. That phrase, self-regulating, it isn't usually applied to comets. It's used for systems, for machines. Could this all be natural? Yes, if we push hard enough. A naturally asymmetric shape, sublimating just right, with mass centered perfectly, might, in theory, settle into this configuration. But theory is not probability. This is not just plausible, it's precise. It's spin behavior with purpose. Next, the spin rate. Data from multiple telescopes, including high-cadence photometry, suggests a rotation period between 10 and 20 hours. That's within normal comet bounds, but it's the consistency that matters. No deceleration, no increase in tumbling. Even during perihelion, where the torque from gas release should be strongest, the spin remained undisturbed. Now think thermally. Heat from the sun. It shouldn't just affect the surface. It penetrates, it shifts internal pressure, it warps the spin. Yet 3I, Atlas, maintained its rhythm. That implies high structural cohesion, low internal porosity, or adaptive feedback. In a spacecraft, spin is maintained through gyros and software, but in nature, spin is usually victim to forces. Here, it resists them. There's another angle, thermal torque. When one side heats more than the other, you get a Yorp effect, a gradual spin change over time. That's measurable. And for 3I, Atlas, no significant change. Again, resistant to perturbation. Or designed to be. Let's now imagine the inverse. Suppose this object were ours, a human-made probe meant to last 1 million years between stars. Where'd spin it for stabilization, where'd align a jet with the axis, where'd regulate material loss, to maintain both motion and orientation, and where'd lock that axis. Toward the star, we visit to power that propulsion and to keep control. That's exactly what 3I, Atlas, is doing. So we face a strange mirror. Either this is the luckiest configuration for a long-traveling rock to fall into, or this is the simplest solution a designer might choose. For a stable interstellar traveler, we must not jump to aliens, but we also must not ignore the design logic right in front of us. Because spin is not aesthetic, it's functional, and 3I Atlas functions with remarkable clarity. Could internal mass distribution be a factor? Absolutely. Simulations suggest an elongated shape, with balanced lobes and internal symmetry, could yield the observed light curve. But symmetry is rare, balance is rare. And here, both are present in an object also showing non-gravitational acceleration without visible ejecta. That's a lot of rare. In one object, now take a step back. Across the solar system, we've observed precessing comets, tumbling asteroids, disrupted fragments, outgassing with chaotic thrust, spin-up leading to breakup. None of them move like 3I Atlas. None of them resist change like this. And none of them spin with the silence E. of something that's been doing this a very, very long time. We may never know what lies beneath its surface, whether it's rock or regolith, metal or memory, but we know how it moves, and movement is the one thing that doesn't lie. Motion is memory. Spin is a story, and this one is being told with precision and patience were the ones catching up to the language. It came spinning through space, quiet, symmetrical, deliberate, and just for a while, under the gaze of our instruments, it lets us read its rotation. Now the question is, were we meant to? It's one thing to look, it's another to know what you're really seeing. And when it comes to something as elusive as 3I, Atlas, the difference between observation and understanding may be as wide as interstellar space itself. We live in a time where space is photographed in breathtaking detail. Arrays of mirrors, CCD sensors cooled to cryogenic silence, data pipelines that reconstruct what no human eye could ever capture. Yet with all that power, we still rely on light. Light that bends, scatters, overlaps, and sometimes lies. And for 3I, Atlas, those lies matter. Let's begin with the most fundamental process, image stacking. To observe something that faint, astronomers don't just take a single picture. They take dozens, hundreds, sometimes thousands, and then they align and stack them, averaging out noise, increasing signal, and bringing the faint whisper of light into clarity. But that process also creates illusions. If you stack on the wrong reference point, say, a star, instead of the moving object, you blur the comet. You stretch it. You might even invent a tail that doesn't exist. Or worse, you erase one that does. Now imagine trying to analyze jets fine, directional features, sometimes narrower than a pixel. One poorly subtracted background frame, one misaligned axis, one batch of motion-blurred noise, and suddenly a jet appears, or disappears, depending on your process. This isn't speculation. It's baked into the history of astrophotography. The story of false detections in astronomy is long and humbling. From canals on Mars to supposed supernovae that turned out to be bugs in the sensor, we've learned again and again that telescopes don't just collect light, they also collect bias. And the observations of 3I, Atlas, especially around the OH jet vector, are particularly vulnerable. In early image sets, especially those taken with ground-based scopes in mid-2024, some observers reported possible jets in the sunward direction. Others saw nothing. Some saw them rotating. Others insisted they were stationary. How can that be? The answer lies in the angle of stacking, the duration of exposure, and the dynamic range applied during contrast stretching. The same raw data, processed two different ways, can produce contradictory visual narratives. That's not a failure of science. It's a reminder that science is a process of disciplined humility. The OH 18cm line detection by MeerKAT offered a solid anchor proof that 3I, Atlas, was outgassing water or its byproducts, but it did not tell us where that gas was escaping from. That's a job for images. And therein lies the problem. One widely circulated photo from August 2025 showed a fan-like feature pointed slightly toward the Sunday. It was interpreted by some as a jet, but deeper analysis suggested the tail-like structure may have been an artifact of anisotropic smoothing, an image processing step that favors horizontal elongation in low-signal regions. In other words, a phantom. Another observatory used a longer stacking window, 120 minutes instead of 30. The object drifted slightly off-center. The result? A stretch signal with a faint trail in the direction opposite its motion. That's classic anti-tail geometry, except it might not have been real. And then came the Hubble batch. Images taken by HST on September 12, 2025, were released with a strong directional bias. Only one of them showed any discernible structure beyond a faint point source. That led some to conclude that only one jet was active. But later, when raw FITS files were reprocessed by an independent team, they showed a symmetrical halo, suggesting either multiple jets or none. This isn't a matter of conspiracy. It's the edge of measurement. We are observing something at the limit of our instruments. 3I, Atlas is dim, moving fast, and venting in ways that resist traditional classification. The difference between two jets, a fan, or nothing at all, may come down to how a few stray photons landed on a CCD chip 100 million kilometers away. And yet, Those tiny differences matter, because if we see a jet that doesn't precess, we question natural models. If we see a stable directionality, we invoke engineering, and if we don't see a jet but still detect non-gravitational acceleration, then we have to look elsewhere: mass distribution, thermal lag, internal pressure. Each image becomes a fragment of a puzzle that no single telescope can solve. Even the best images are shaped by expectation. Observers know what to look for: tails, fans, dust trails. But that knowledge can subtly influence processing. It can lead to oversubtraction, understretching, or selective focus. It's not deception. It's human pattern matching applied to inhuman data. In one review paper from the Rubin Observatory team, the authors noted that structure is often inferred where no statistical confidence exists. In other words, the mind fills in. When we see something in a comet photo, especially a comet as weird as 3I, Atlas, we're not just seeing the object, we're seeing a model of it projected onto the raw light, and sometimes that model outshines the truth. So what don't the images show? They don't show a dust trail behind 3I, Atlas. They don't show fragmentation debris. They don't show a classic parabolic coma. They don't show rotational blurring or fan dispersal. They don't show a swarm of particles. They don't show what we expect from a comet this active. Instead, they show something colder, cleaner, more focused, something that seems to know how not to leave a mess. That absence becomes its own kind of data. And in that silence, we are reminded that not everything seen is true, and not everything true is seen. When science reaches its edge, the next step isn't certainty, it's caution. And in the case of 3I, Atlas, that caution is written in every pixel. We are not afraid to look closer. We are afraid to assume we already understand. Because if there is one thing this visitor has taught us, it's this: you can capture the light without capturing the truth. And that truth might be hiding in the shadow behind the image. It passed the test that shattered others. There's a strange kind of admiration in physics, not for what explodes, but for what doesn't. See 2025. K1 was a test case. It looked active, accelerated fast, and then, just past perihelion, it began to fall apart. The signature of sublimation-driven jets was undeniable, but so was its end. A fragile nucleus exposed to solar radiation couldn't survive the thermal stress. That's normal. That's expected. That's what comets do. 3I. Atlas didn't. It spun. It jetted. It rotated near its axis. It showed signs of CO2, outgassing, O8 production, and non-gravitational acceleration, and yet it passed through the same crucible of heat and emerged intact. Why? If we follow the traditional model of a loosely bound icy nucleus held together by volatile rich layers, then this should have gone differently. Models developed for objects like ISON, or even Borisov, would predict fragmentation thresholds at specific thermal inputs. These models aren't hypothetical, they're empirical, based on dozens of cometary observations over the last 5 decades. Yet when you apply those same thresholds to the light curve and solar energy exposure of 3I, Atlas, they fail to predict survival. This isn't about faith, it's about margins, heat energy in, structural stress out. So why didn't it break? Let's begin at the most generous end. Maybe it was just unusually solid, denser, perhaps, than expected. Maybe, as some astronomers proposed early in its trajectory, it was a monolithic chunk more akin to an asteroid with volatile pockets than a dusty snowball. But that too raises questions. If it's solid, where do the jets come from? CO2 and OH signatures suggest some kind of outgassing, but the volume required to produce the observed acceleration implies a porous interior structure capable of gas expansion and channeling. In other words, you can't have strong jet thrust without room to generate pressure. You need pathways, fractures, pockets, release valves. So which is it? Dense and unyielding, or hollow and active? This is where the paradox emerges. There's a concept in structural mechanics known as non-uniform resilience. It's the ability of a body to absorb stress differently across its own surface due to internal configuration. Think of an airplane wing. It's light, hollow, but incredibly strong due to internal bracing. Could something similar be happening here? Could 3I, Atlas, be composed of alternating layers, dense crust, volatile rich interior, and thermal shielding from its own CO2? Some thermal simulations now being run retroactively suggest that CO2 outgassing at certain depths could act as a kind of thermal buffer venting heat before it penetrates deeply. In this model, a venting layer just below the surface might continually release pressurized gas that cools adjacent layers via evaporative effects, slowing core heating. A comet that self-cools. If true, this would explain how a relatively small interstellar visitor could absorb solar radiation far above the known tolerance of similarly sized comets without shattering. But the math gets tight. To maintain structural coherence during perihelion, the energy differential between solar input and internal redistribution would have to be finely tuned, not random, not noisy, not erratic, like we see with most objects that develop temporary venting events. It would need consistency, precision, and that's unsettling, because natural randomness is noisy by default. Fractures widen inconsistently, sublimation occurs along stress lines, not symmetry axes. That's why most comets look chaotic up close. Their tails aren't clean streams, they're war zones of thermal imbalance. But 3I, Atlas, shows directional consistency in jet alignment, stability in spin, and critically a lack of structural decay. At this point, you might think, okay, maybe it's just lucky, maybe the fracture angles happen to vent in the right way, maybe the gas release just happens to keep the core stable, maybe it just looks engineered because nature, occasionally, gets poetic, and maybe it is. But let's ask, what else didn't happen? It didn't split, it didn't fade, it didn't get brighter unexpectedly, it didn't release observable debris after perihelion, it didn't shed a secondary nucleus, it didn't enter spin instability, it didn't even display thermal runaway at peak isolation. Each one of those is a statistical expectation for a volatile rich object this close to the Sunday. And 3I, Atlas defied everyone. Instead, what we saw through MeerKAT detections, long exposure composites, O8 lines, light curves, and JPL tracking was an object that behaved with an odd consistency. And consistency is a problem, because comets aren't consistent. They're improvisers, not engineers. They tumble, they fracture, they reveal their inner chaos the closer they get to heat. 3I, Atlas, didn't, so we're left with this. Either we've discovered a type of comet so rare, so exceptionally well built, that it breaks the thermal survival envelope, or something else is holding it together. Maybe it's not about what we see, but what we don't. No visible secondary fragments, no light spikes post-perihelion, no thermal surge, and most unsettling of all, no damage, despite the forces that should have torn it apart. Like a submarine that dives through pressure zones where others crush, and surfaces without a single rivet displaced. What kind of blueprint allows for that? The answer, right now, is silence. We watch, we measure, we model, and still the nucleus holds. It turns beneath the sun, releasing just enough to move, but never enough to rupture. And if that sounds like control, it's because, perhaps, that's what it is. A choreography of survival, written not in equations, but in motion. One that left no trail, and no explanation. An X marks the place. But this time, it's not on a map. It's in the sky. There's a moment when chaos begins to look like code. For days, the composite images of 3I, Atlas, were nothing more than a blur. Ghosts layered on noise. A trail of guesses, stitched into pixels. But then came the frame, the one where the light bent, crossed, and held. The one that didn't fade with contrast adjustments. The one that, no matter how we tried to reprocess it, kept saying the same thing. There's an X. It wasn't in the tail. It wasn't in the coma. It wasn't even in the structure of the jets alone. It was in alignment. Two jets, opposing, stable, holding vector, crossing planes not at random angles, but close to 90 degrees, suggesting internal symmetry. At first, it was easy to dismiss. Image stacking can do strange things. Point spread functions can overlap, distort. Residual noise, perhaps, but when multiple observatories with different instruments and orientations began reporting the same crossing lines in similar positions relative to the object's spin axis, skepticism began to thin. Let's pause there. Because we don't want to mistake beauty for design. Nature is full of symmetry. Snowflakes, spiderwebs, Saturns, rings. But this isn't about aesthetic symmetry. It's about functional geometry, the kind that emerges when energy must be directed, stabilized, and repeated. If you're trying to vent CO2 from an interstellar object while maintaining spin integrity and controlled acceleration, this is exactly the pattern you'd want to see: opposing jets that cancel torque and maintain angular momentum while enabling non-gravitational movement. And that's what this X implies. From a dynamic standpoint, two stable jets at near perpendicular ejection points could explain how 3I, Atlas, avoids tumbling, how it maintains orientation, how its motion so smooth it almost defies gravitational tug stays so coherent across weeks of observation. Still, a pattern isn't proof. So, we dive deeper. On May 12, Vera Rubin Observatory's image analysis system flagged an anomaly in the object's jet signature, not because of brightness, but because of angular uniformity. The radiance distribution wasn't chaotic, it was bilaterally consistent. This means the intensity of light being reflected or emitted along both sides of the jet path showed near-identical tapering, an indicator of mirror-like opposition. Translation: both jets were firing not just consistently, but in coordination. This level of angular stability suggests either a deeply embedded rotational symmetry or intentional vent design. And that's where the narrative starts to buckle. Because every natural jetting event we've catalogued, whether from Oort cloud comets or sun-grazing fragments, features drift, precession, and wobble. Jet sources change. They migrate along stress fractures. Even stable comets rarely maintain an identical jet angle over a full spin cycle. 3I Atlas? It hasn't shifted. If this geometry is correct, and data from ALMA, MeerKAT, and the Subaru telescope suggest it is, then we're looking at something that has retained structural jet alignment across multiple solar exposures. That's not luck, that's architecture. The question is, architecture of what? Let's go back to the images. When you layer the jets with the rotational axis, a shape begins to emerge. Not a sphere, not a random lump of ice, but a frame, a cross-structure. Two opposing emissions form a stabilizing plane, almost like the arms of a gyroscope. And that shape, that consistency, that refusal to decay into asymmetry starts to suggest not just symmetry, but intent. Why does that matter? Because geometry is one of the oldest signatures of thought. Symmetry is efficiency. Engineers use it to distribute stress, balance load, and preserve motion. So does nature. But when you find symmetry under duress, when radiation, rotation, and gas pressure are all trying to tear a body apart, that's when symmetry becomes a question. Not a conclusion, not evidence, but a question worth asking. Could the jets have emerged randomly like this? Could thermal expansion fractures just happen to align in a way that perfectly preserves rotational balance while also creating consistent thrust? Yes, in theory, but only under conditions so narrow, so fine-tuned, that even the probability curves start to wobble. So maybe the X isn't a message, maybe it's not a symbol, but it's still there. And in the absence of fragmentation, in the presence of stable outgassing, in the calm of a coma that doesn't glow like it should, we're left with an image that our minds keep returning to. Not because we want to believe, but because we can't ignore what the data keeps repeating. The jets cross, they cross precisely, and they don't stop. One rotation later, and we might have missed it all. It's strange to think how close this all came to being nothing. If 3I, Atlas, had rotated 5 degrees faster, if Earth had been just a few hours deeper in its orbit, if a single telescope in South Africa hadn't stayed open an extra night, there would be no signal, no jets, no anti-tail, no story. Just another dim speck in a crowded sky. This is not romanticism. It's logistics. When you're tracking an object that rotates roughly every 16-18 hours, every observation window matters. And 3I, Atlas, was unusually coy, its active regions only flaring at particular sun object angles, its geometry making certain features nearly invisible from most northern hemisphere observatories. Only a narrow sliver of time allowed the OH-18cm line to peak in signal during a MeerKAT array pass that almost didn't happen. The observing slot had been booked for a different target, but a last-minute reschedule, triggered by weather, freed a window. And that window, just under 2.3 hours, was exactly when 3I, Atlas, rotated its vent-facing side toward us. That's when the signal screamed, And it didn't just whisper jets. It sang rotation, phase-locked intensity, a rhythm tied not to chaos, but to clockwork. I missed that window, and all you have is silence. Now imagine how many of those we did miss. How many other objects tilted just slightly differently? How many vented at frequencies our instruments weren't listening to our instruments? How many passed in daylight, or behind the moon, or during maintenance downtime? This wasn't inevitable. It was chance layered on timing, layered on error margins, all stacked just right to make this discovery possible. Even the anti-tail, an optical artifact of dust motion aligned sunward, could only be captured because we happened to have an image stack calibrated to remove background noise in exactly the opposite direction. If it were a week later, the solar angle would have inverted. Nothing visible. So many near misses. And yet here we are, the faint shadow of a CO2 jet, observed not directly, but as a discrepancy in the infrared flux of the coma's trailing edge. The difference? Just 0.2 Kelvin, barely above instrumental noise. But it was enough. Enough to raise a flag. Enough to trigger a reanalysis. Enough to say, look again. And what about the X? That cross-jet geometry only appeared in a single full-frame image from the Subaru telescope, captured during a calibration run. It wasn't even part of the main observing sequence. A tech left the camera running during a flat-field scan. It wasn't supposed to be archived, but the software logged it anyway. And in that ghost frame, the angle, the flare, the impossible symmetry, saved by a bug, we came this close to missing it all. It's humbling, but it's also instructive, because if one object, like 3I, Atlas, can only be understood by luck and edge case data, what does that say about the rest? How much of the sky are we seeing through keyholes? How many stories have slipped through the cracks because our windows were too short, our instruments too rigid, or our eyes too focused on what we expected to find? This is the quiet lesson behind the noise. Vigilance isn't about knowing what to look for. It's about watching even when you're not sure why. The next 3I, Atlas, may already be here. Dim, misaligned, missed by schedules, filters, or priorities. But it's not about catching them all. It's about not forgetting that most of them will only whisper once, and that whisper might not even sound like what we think. There is no cosmic notification system, no reminder, no retake. There's only one truth. Sometimes the data waits for us, but most times it doesn't. Everyone saw the same images. No one saw the same thing. The moment the cross-jet photo hit the internet, the narrative detonated. Within 12 hours, there were 40 TikToks claiming the object was alive. Within 18 hours, Reddit's aliens pinned it as probe activity. Within 36 hours, 2 mainstream outlets quietly quoted anonymous NASA engineers. And within 48 hours, the memes started. Not just one, not just speculative, viral, a green object, 4 limbs, framed by light, tagged he is risen. A composite of 3I, Atlas, next to the James Webb photo of Arundel, with captions like, "Bro came to pick up his kid." Another showed the OH radio line next to the Wi-Fi symbol, captioned, "Connecting." But it wasn't all jokes. Comment sections on Calm Space channels swarmed with posts like, "NASA lied again. This is Oumuamua too, and they know it. Why does this look engineered? Look at that symmetry. No comet has jets this stable. Something's off." Some called it a spacecraft. Some called it an interdimensional glitch. Some thought it was a metaphor. Some just laughed. One video with 3 million views featured a split screen. On the left, the MeerKAT detection of the OH 18 cm line. On the right, a sped-up simulation of the object's rotation, with fake lights turning on and off to look like thruster bursts. The title? You Still Think This Is a Rock? It wasn't serious science, but it resonated. Whether or not people understood the chemistry, the vent geometry, or the rotational dynamics, they felt something uncanny, something scripted, and that was the cultural supernova. Not proof, but pattern. People don't respond to data, they respond to the story. And this object, jetting without chaos, flaring without breaking, spinning without precessing, told one, even if science hadn't written it. In the void of explanation, imagination moved in. Conspiracy forums linked it to an old Voyager message. Some tied the geometry to ancient symbols X, cross, tetrahedron. There were claims that it matched ley lines, that's its spin synced with Schumann resonance, that it was the Eye of Horus, that it wasn't a comet but a clock. And beneath the noise, some feared it meant something else entirely. Not aliens, not simulation, but that we're too late to understand what's already passing. This was the quieter, more unsettling current. We were told to look for an invasion, not translation. What if it's not a ship, but a sentence? You don't send a probe unless you've already moved on. It's easy to dismiss this all as hysteria, internet culture doing what it does best, memes, myths, mass projection. But it reveals something critical, the need to assign meaning, because science demands time, but the internet doesn't wait. While researchers debated spin curves and gas signatures, the public had already decided, not on one story, but on hundreds, overlapping, clashing, echoing, and in that cacophony, the original image became less a measurement and more a mirror. The object didn't change, but the world was watching. It did. It fractured into awe, irony, hope, denial, fear, poetry, and what emerged wasn't knowledge. It was a reflection, a map of what we believe, not what we know. That's what makes this visitor so powerful. Not just the physics, but the reactions, the cultural diffraction of a moment we weren't prepared to interpret. The world saw the same photo and turned it into prophecy, parody, panic, and prayer. What does that say about us? Maybe more important than what it says about it. The sky didn't change, but maybe we did. When the dust settles, when the probes go dark or fade or drift too far to track what stays behind, not the data, not the models, not the frames per second or signal-to-noise ratios. What lingers is something older, something more human, a memory, not of numbers, of questions. And in the wake of 3I, Atlas, the questions didn't just point outward, they turned inward, because the object didn't tell us who sent it, or whether it meant anything, or why it flared. It only showed itself, in fragments, in silence, and we humans filled the rest. We assigned intentions, projected stories, wove metaphors, built warnings. We called it a probe, a glitch, a sign. We said it was too stable, too clean, too timed. We whispered, it knows. But here's the thing. Maybe it never said anything. Maybe the voice we heard was our own. Because that's what unexplained things do. They don't just challenge science. They challenge perception. They offer a blank canvas, and we inevitably paint it with fear, with wonder, with meaning we desperately want to believe is true. So what did we see in 3I Atlas? Not a comet, not a spacecraft. We saw a mirror, and in it we saw the fractures in our own belief systems. The scientists who demanded patience, the skeptics who saw engineering, the believers who saw messengers, the curious who saw possibility. Each of us, standing under the same sky, projecting something different onto the same streak of light. This isn't the first time. History is full of skies misunderstood. Halley's comet once heralded doom. Oumuamua split opinion. The Tunguska blast remains half myth, half science. And every time the unknown passes overhead, we ask not just what it is, but what we are. Do we trust only what can be measured? Do we allow mystery to live beside reason? Do we need certainty more than we need truth? 3I Atlas didn't violate laws of physics. It bent our confidence in them. It didn't arrive with a message, but it triggered every one we've stored in our collective memory, from alien dreams to apocalyptic fears. And it didn't explode, but something in us might have. A quiet rupture, a reminder that, for all our telescopes and equations, we're still creatures who stare at the stars and wonder not just what, but why. So maybe this isn't about whether it's natural or artificial. Maybe the real event is how we respond to what we can't explain, how we frame the unframable. How do we carry uncertainty? Maybe what matters is how we look up, because when the light fades, the press releases end, and the headlines scroll, and what remains is not an object, it's a choice. To stay curious, to stay humble, to stay open to things that ask more than they answer. That's the mirror this object held to us, and that's the reflection we now carry forward. Part 18. This visitor's origin story. It formed around another star, before it flared, before it curved toward our Sunday, before the probes, the silence, the questions it belonged elsewhere. Not here. Not in this system. Not in this chapter of cosmic time. It was born maybe at the edge of a blue-white star's gravity, not unlike ours, but older, a long-dead solar system, distant not just in light years, but in memory, a place whose worlds may no longer exist, whose planets may have burned or frozen, whose sun may have dimmed into a red dwarf or blinked into silence. But once, long ago, in that system, something formed. Not a planet, not quite a comet, something different, denser, more stable, more deliberate in its design or in its survival. And then, at some moment lost to our calendars, something shook it free. Maybe a planetary migration, maybe a passing star, maybe the slow, patient hand of the galactic tide, the gravity of the Milky Way nudging it from its orbit. It drifted. Slowly. For millions, perhaps billions of years. No engine, no sail, just motion and memory. And in all that time, it never stopped. It crossed between the arms of the galaxy, past stars that came and went, skipped through dark clouds, silent voids, radiation storms, and somehow stayed intact. No fragmentation, no spin that tore it apart, just a quiet persistence across distances we can barely model. And then something aligned. The sun's gravity reached far enough. Or maybe we drifted into its path. Either way, its silence intersected with our gaze. And the visitor, this relic of another system, began to glow. It wasn't calling for attention. It was reacting. The heat, the photons, the geometry of its surface. It vented, it flared, it curved, but not like a comet, more like a carrier, because what followed was not chaos, but symmetry. A vent pattern, a spin axis, a consistency that startled those watching closely. Could it be a delivery system, a slow, ancient probe, not powered by speed, but by endurance? Not the kind that beams back telemetry, but the kind that waits, that travels far enough, long enough, to find systems like ours, to see who notices, to test the conditions, to leave a trace in a place that might be watching. Is that what it is? We don't know. We may never know. And not just across space, but across time. It may be older than our species, older than our myths, older than our oceans, and it survived long enough to pass near our planet, near our instruments, near our imagination. And what it showed us, it was not just where it might be from, but what kind of stories do we tell when something survives that long, that silently? Because the story of 3I, Atlas, is not just about where it went, it's about how we witnessed it, and how a tiny fragment of ancient matter, barely visible to the naked eye, reminded an entire civilization that we are not the only system to produce survivors. We are, perhaps, not the only ones. To send something out, or to wait for a reply. We solved nothing, but we mapped the questions. It's easy, now, to believe we know what happened, that the object came, that we tracked it, that our instruments told the story. But step back, start at the beginning. We thought it was gone. It wasn't. We thought it was dust. Then it wasn't dust. We thought it would explode. It didn't. We thought it was natural. Now, we don't say that so easily. Along the arc of its approach, across the weeks and months of silent observation, we accumulated more than light curves and emission lines. We accumulated contradictions. Here is what we know. It is real. It is moving. It is jetting. It is spinning. It passed near the Sunday. It should have broken apart. It didn't. It emitted OH at 18 centimeters. It showed no visible coma. Its jets don't precess. Its spin doesn't match the expected outgassing dynamics. Its structural coherence defies sublimation models. Its image structure shows an X that's geometrically precise. Each of those sentences is a thread. Each thread leads, not to a tapestry, but to a tangle. So what have we actually learned? We've learned that motion doesn't require a tail, that jets can be invisible, that absence of dust isn't the absence of activity, that thermal input doesn't always equal fragmentation. We've learned that signals can hide in noise for weeks before reappearing like whispers that never left. We've learned that humanity's collective model of what a comet does isn't universal. We've learned that even the most sophisticated simulations fail when they're fed something that wasn't supposed to exist. And maybe most importantly, we've learned that unidentified doesn't always mean unknown. Sometimes it means unmodeled. Sometimes it means too early. Sometimes it means not ours. And here's what we haven't learned: what its true origin is, what its structure looks like beneath the surface, whether its spin is passive or managed, what triggers its jet activity, why did it survive, what it left behind, whether it's unique or the first of many. We haven't learned who's right. We haven't learned whether we were ever asking the right questions. We haven't learned whether this is science fiction or just science in progress. But we've started something more powerful than certainty: a map of inquiry. We now know what matters. We know which assumptions to test. We know that OH at 18 centimeters can appear without a cometary coma. We know that stability doesn't mean inactivity. We know that the absence of heat signatures doesn't mean the absence of function. And above all, we know the price of silence. That if we don't ask, we don't see. And if we don't see, we miss everything. So maybe the object itself wasn't the lesson. Maybe the lesson was for us, our instruments, our debates, our arrogance, our awe. Because every time we thought we'd closed the case, it opened again. Because every time we leaned back into certainty, it drifted just slightly out of reach. It didn't shout. It didn't warn. It didn't demand belief. It simply passed through. And what remains is not a conclusion. It's a shape, a shadow, a pattern in the silence. We didn't solve it, but we're watching differently now. Not with answers, but with better questions. Whatever happens next, we saw it. There's a moment every observer knows. It has nothing to do with equipment. The dome opens. The hum of the motor fades into long, patient quiet. Your eyes adjust to the black-on-black geometry of the sky. And then, there it is. A dim smudge you've chased for weeks finally drifts into frame. It isn't bright. It isn't noble. It's a grain of ash drifting through the cold. But it does something only the sky can do. It rearranges you. We watched 3I, Atlas first, through noise, then through knowledge. A dot became a curve. A curve became motion. Motion became a visitor. A visitor became a question. Then the question became several. Then a field of unresolved tension. But through all of that, something remained. We didn't watch because we were afraid. We watched because we remembered what not watching once cost us. In 1908, a flash over Tunguska. No warning, no data, a scar in the trees, and silence. In 2017, Oumuamua slipped past, seen only after its escape. No spectra, no tail, no second chance. In 2019, Borisov came a true interstellar comet, but familiar, predictable, observable. And then came this. Not bright, not loud, not easy, not simple, not giving us what we asked, but giving something else. The chance to observe not just what it was, but what we are when we observe. Because here is what changed. We saw ourselves asking better questions. We saw scientists argue with integrity. We saw forums overflow with wonder instead of fear. We saw silence treated not as emptiness, but as possibility. 3I, Atlas, whether by chance or by intent, became a mirror. And in that mirror, we saw the outlines of our curiosity, bent, fragmented, scattered in time, but still reaching. Even as we debated OH lines and spin axes, even as we puzzled over geometry and survival, there was a quiet rhythm behind it all. A breath, a pause, a recognition. Something was watching us back, not necessarily with eyes or motive, but with presence, with timing, with the unrelenting cadence of something not meant to be ignored. In the final days before closest approach, dozens of telescopes turned their gaze, not because they were told to, not because they believed in aliens, but because they couldn't not look. Something in the geometry demanded attention. Something in the motion resisted indifference. And in that shared attention across labs, languages, and latitudes, we became something rare. A species synchronized by wonder. We didn't launch a probe. We didn't send a message. We didn't alter its path. But we witnessed, and that may be enough. Because sometimes history doesn't come with certainty. It comes with stillness, and that stillness is what marks a threshold, not of knowledge, but of readiness. The legacy of 3i, Atlas, may not be a discovery. It may be a calibration, a resetting of how we see, how we listen, how we remember. Because memory, too, is a form of light, and what we remember, we make real. So now the object moves on, away from the Sunday, away from us. But it leaves behind the shape of a question, one we can't unask. Not because it's unanswered, but because it answered us. In our silence, in our instruments, in our pulse. It flared, it turned, it didn't break. And that changed something. Not in the sky, but in the species watching it. And maybe, just maybe, that was the point.